Do an AP Physics problem from the Fundamentals of Physics. It's the 7th edition book. And today we're going to be doing a chapter 2 problem, number 57. So let me zoom that in a bit more. Okay, so it says a steel bar is dropped from the building's roof and past a window, taking 0.125 seconds to fall from the top to the bottom of the window, a distance of 1.20 meters. It then falls to a sidewalk and bounces back past the window, moving from bottom to the top of 0.125 seconds. Assuming that the upward flight is in exact reverse of the fall, the time the bar spends below the bottom of the window is 2 seconds. How tall is the building? Okay. So ways to approach. Well, the way I solved it was, first, obviously, you want to solve for, you want to draw what the problem said, so it could be much easier and faster to approach. Alright, let's draw the building. So let's say the window's right there on the building. The steel ball was dropped from here, and it fell up to here, which was given. Delta y, let's call it 1 equals 1.20 meters, and the time it took from there to here was 0.125 seconds. Okay, so then the ball continued and kept on going. The time that it spent below said was, let's put below, 2 seconds, and it was about the same. Okay. Wait, no, sorry, my bad. Alright, so let's solve for this. And the question was, we want to know how tall is the building, assuming from what was given. So we want to solve for the velocity, the initial velocity for here. Okay? So we're gonna say delta y1 equals v initial t plus 1/2 gt. And so we plug it in from what was given. The initial, it's not given, so we gotta solve for that. And we all know that gravity is 8.9 meters per second square, or acceleration, whichever. Okay. So then, if you guys have a TI inspired cast, or just inspired, or a TI 89 titanium, it'll be much easier, much faster. You'll solve for you can solve for V. So I use a TI inspired cast. So I use a solver. So V initial was 8.19875 meters per second downward. Remember, it's downward because we're doing it from here to here. Okay. So now we want to find how much distance it took from here, and that it's not given specifically. But what we could do, simply use, well, we could say that the initial is 0, first of all. So the equation I used was F final equals v initial square plus 2a of delta y2. Let's call this delta y because that's what we gotta solve. Okay? Alright, so v initial obviously is 0. And there's gonna be 9.8 meters per second square. And this, the v final will be coming from here. So let's rewrite this so it can be much simpler to understand. Don't forget square. Again, I use a TI Inspire cast, so I use solver, And I got 4.1212 meters. Alright, cool. So I'm going to rewrite it again. So my delta y 1 was 8. No, my bad. No. Okay. So now, going back to this, let's solve the total height from there. Let's call this h. So from the equation that we used previously, which was delta y equals v initial t squared plus v gt. We could use this to find how much it took the total distance of this. Okay, the only difference is that we're gonna say h because we don't know exactly what is this, but we have this. So assuming and thinking that we have the overall and subtracting this, we get the total distance height. Okay, so we're gonna say minus delta y 2 equals the velocity that we solved initially for this part. So 8.987 meters, and the seconds, obviously it was given 0.15, and then we do this again, 9.8, and then times. Okay, so because like I said, I have an inspire, well, I could rewrite this a little bit cleaner. Minus 4.1212 meters equals 8.19. So overall h, I'll be getting 1.41337 meters. So that's how much distance the bot took from traveling from top to here. I double checked in the back of the book, and there you go. I hope this helped.